Today we're going to be solving exponential equations. We will focus on getting the same base today, and then tomorrow we'll learn different methods. So when you are solving an exponential equation, if both sides have the same base, all you have to do is set the exponents equal to each other. The reason why is if the bases are the same, the exponents have to be equal. So we would take 3 minus 2x, set it equal to the opposite of x, and then get your x's on one side. And then in this case, we are done. Cool thing about exponential equations, just like in the last unit, is you can always check your answers by subbing that answer in and making sure both sides are equal. Since the domain of these is all real numbers, you don't have to worry about extraneous solutions yet. Dun, dun, dun. So for the next problem, same idea. If the bases are the same, all we have to do is set these exponents equal, and then we can go through and solve. So if I add 2p to both sides, I get 4p equals negative 1, and then I get a value of p equals negative 1/4. Now, for the next set of problems, you're going to notice right away when you look at them that they don't start with the same base. That doesn't mean we can't use this method, but we have to actually get the same base first. Notice that we can actually rewrite 5 squared. I gave away the answer. We can rewrite 25 as 5 squared. And if we do that, we have not changed the quantity of 25. We've just rewritten it in a different way using exponents. Now, because the bases are the same, we are now okay to set the exponents equal to each other. So we get that 2x plus 7 equaling 2, and then we can go through and solve. Here's another problem over here where they don't start off with the same exponent. But we can easily get that by rewriting in terms of the same base. I apologize, I said exponent, I meant base. So think about how 32 can be rewritten as 2 to the 5th power. And then from there, we can set those exponents equal to each other. Now, there's a couple more problems down here where it gets a little bit more challenging because of the type of exponents you're using. Here, this looks very complicated, but when you think about it, if I were to cover up the 1 on the top, I can't do this with my finger, but let's just say that this 1 wasn't here. If I said 3 to what power is 9, you would say to the 2nd power, 3 squared. But it's 1/9, the reciprocal of 9. Well, I'm hoping that right away you're thinking, oh wait, that's a negative exponent. We can actually rewrite 1/9 as 3 to the negative 2nd power. And by doing that, you get the same base. So then we can set these exponents equal, and then wham, bam, thank you, ma'am. We can solve. And get that answer of 3/2. Now, the final problem in this set, same idea. You're going to see that it looks like these numbers are very different, the bases. But remember, anything raised to the 0 power equals 1. And so we can take that same base of 4, raise it to the 0 power. We have these exponents that we can now set equal to each other, and then we can go through and solve. All right, so that's the first page of notes. Let's go to the next set of examples. In the next set of examples, you're going to notice that they have an operation included with the problem before we even begin. So let's use our properties of exponents that say when you have the same base, we can add these exponents together and then use what we did on the front side. Now we need to get the same base, so we need to think about how I can rewrite 64 as possibly 4 to some power. Well, I know that 64 is 4 to the third power, and then I can set those exponents equal to each other. There we go. And really cool, like I said, you can always sub that in and check your solution to see if it's correct. Going to the last problem in the set, same base. So we can use the properties here to rewrite that as a base of 10 and then add our exponents together. This problem's unique because the exponents have a sum. So just add like you normally would, combine like terms. We have 2 x's and then that 5 and then all equal to the 1/10. And then from here, remember we want to get the same base. So we can rewrite the right-hand side using negative exponents. Notice that I can just use a -1 because that would give the reciprocal of that base of 10. And then we can go through and solve. We're going to subtract 5, so that's going to be a -6. So what I would like for you to do at this time is pause the video and try the next 4 on your own. When you're ready to check the answers, please unpause the video and then you can see an explanation of each, or just scroll to the end of the video and check to see if you got all 4 correct. Pausing now. Hey, welcome back. So this is the work for the next 4. For this one, you could just set the exponents equal since they already have the same base. When you add the 3x, you would get, or 2x, you would get 3x on the other side. And then you could divide by 3 to get x equals 2. For the next problem in the set, they don't have the same base, but we can rewrite 49 as 7 squared. And then once we do that, we can set our exponents equal. Getting a lot of 3/2, so that's not cheap. On the next problem, they do not have the same base, but I'm seeing a fraction, which makes me think negative exponents. I can rewrite this as 5 to the -3rd power, and then I can set my exponents equal. And there we go. And then the final problem in the set, using the properties, we can combine this into 6 to the 2x plus 4 power, because remember we're adding those exponents. Then I don't have the same base, but I do know that if I take that 1 and rewrite it as 6 to the 0 power, I could then solve for x. So there you go. Let me know if you have any questions.